Dark matter and dark energy, the invisible forces shaping the universe. Imagine looking up at the night sky. You see stars, planets, and galaxies stretching across the cosmos. But what if I told you that everything we can see, all the galaxies, stars, and planets, make up less than 5% of the universe? The other 95%? It's completely invisible. Scientists call it dark matter and dark energy, two of the most mysterious forces in the cosmos. We can't see them. We can't touch them. But they shape everything in the universe. So, what exactly are these invisible forces, and how do they control the fate of the cosmos? Let's explore the greatest cosmic mystery of all time. The unseen universe. For centuries, we believed the universe was made of what we could see: stars, planets, gas, and dust. But in the 20th century, scientists noticed something strange. Galaxies were spinning too fast. According to the laws of physics, galaxies should fly apart, yet they don't. Something unseen was holding them together, a hidden mass we now call dark matter. But that was just the beginning of the mystery. Later, astronomers discovered something even stranger. The universe isn't just expanding, it's expanding faster and faster. Something is pushing galaxies apart at an increasing speed. They named this force dark energy, an invisible, unknown power that dominates the entire universe. Together, dark matter and dark energy make up 95% of everything that exists. And yet, we still don't know what they really are. What is dark matter? Dark matter is the cosmic glue that holds galaxies together. It has mass, so it exerts gravity, but it doesn't interact with light, which is why we can't see it. Scientists discovered dark matter by observing galaxy rotations. Normally, stars on the edges of galaxies should move slower than those near the center. But in reality, they don't. They move at the same speed, as if an invisible mass is pulling them along. So what is dark matter made of? Some theories suggest it could be WIMPs, weakly interacting massive particles, hypothetical particles that barely interact with normal matter, axions, ultralight particles that might explain dark matter's strange properties, primordial black holes, tiny black holes left over from the Big Bang. But no one knows for sure. We are hunting for dark matter in underground labs and giant particle detectors. If we find it, it could rewrite physics as we know it. What is dark energy? Dark energy is even more mysterious. Unlike dark matter, which pulls things together, dark energy pushes things apart. Think of it like an invisible force that makes the universe expand faster over time. In 1998, astronomers studying distant supernovae, exploding stars, made a shocking discovery. The universe's expansion was accelerating. Something was overpowering gravity and stretching space itself. That force is what we call dark energy. But what is it? Some theories suggest vacuum energy. Empty space isn't really empty. It's filled with energy that repels itself. A new fundamental force. Just like gravity and electromagnetism, dark energy could be a completely new force in physics. A flaw in Einstein's theory. Maybe our understanding of gravity is incomplete, and dark energy is a clue to something bigger. But here's the real mind-blowing part. Dark energy controls the fate of the universe. Will the universe end? Because dark energy is pushing the universe apart, scientists believe it will determine how everything ends. There are three main theories. The Big Rip. Dark energy grows stronger over time, eventually tearing apart galaxies, planets, and even atoms until nothing remains. The Big Freeze. Dark energy stretches the universe so much that everything becomes cold, dark, and lifeless as stars burn out one by one. The Big Crunch. Dark energy might reverse, causing the universe to collapse back in on itself leading to a new Big Bang and possibly another universe. Which one will happen? No one knows. But dark energy holds the answer. How will we solve the mystery? Right now, scientists are racing to understand these invisible forces. Some of the biggest experiments include the Large Hadron Collider, LHC, smashing particles together to create new forms of matter. The James Webb Space Telescope, looking deep into space for clues about dark matter and dark energy. The Euclid Space Telescope, launched 2023, mapping billions of galaxies to reveal how dark energy is shaping the universe. If we crack the mystery of dark matter and dark energy, it could change everything. It could lead to new physics, new discoveries, and even unlock the secrets of the cosmos. So what do you think? Could solving dark matter and dark energy lead to the biggest scientific discovery of all time? Or could we be completely wrong about everything we think we know? The universe is a puzzle, and we've only just started putting the pieces together. If you enjoyed this video, hit the like button, subscribe for more cosmic mysteries, and let's keep exploring the universe together. Until next time, keep looking up, because the answers might be out there.